So it's 2024, and I think this is the right time to understand and dive into some of the thoughts on the state of cloud native in 2024. So every year there are new trends that get set up. And in this particular video, I'll be going through some of those trends with respect to some key areas with respect to cloud native. Let's begin the state of cloud native 2024, in my opinion. My name is Sam Pathak, and I work as a field CTO at Civo, building the next gen simplified Kubernetes service on Civo. I'm also a CNCF ambassador, author of CKS and CK scenarios. I updated the book very recently, organized DevOps Days, KCD, Civo Navigate, founder of Cube Simplify, the community to simplify cloud native. And you can find me on X platform at the rate Saiyam Pathak. So let's first start with very interesting question, which is what is cloud native? Now, the thing is, over the years, the term has evolved a lot. The tools have evolved a lot. The technology has evolved a lot. And so is the definition. Because if you ask, what is DevOps? And everyone will have their own set of definitions for that. Similarly, for cloud native, it becomes interesting because everyone has their own view, and I'm going to share my view. So basically, data centers. So data centers are placed in some locations across the globe, and then those data centers, the cloud is formed on over those data centers. Basically, what that means is whenever you want a machine to run your workload, you via an API call, basically that's a CLI or a UI. Behind the scenes, it's just an API call that you are doing, that a cloud provider has created for you to consume the resources which are running on their data center. So you can request for, a 20 gigs of machine and X TB of NVMe drives to run your workload, and you'll get it within a few seconds or within a few minutes. That's how simple cloud has made things for us. So over the years, I believe you can call cloud native as a philosophy, because it not only democratizes how you deploy or develop and deploy your application, it is also a shift from how you think of deploying and developing your application. Cloud native is a philosophy. It is running your application in clouds with the modern tooling. So if you think back of the pre-era, like the when you only had, EC2 or, some few services which are there, no containerization era, that time running an application in cloud means you are just renting a virtual machine from a particular vendor, and then you are running your application and you're not using your data center. So the philosophy evolved from there. Then the process evolved. You got new philosophies of DevOps. You got new cultural philosophy, how to adopt those tools and make this cloud native. So we can see VMs in the cloud, and then more and more services, as we saw more and more services in the cloud coming in for the application and ease of development and deployment. So everything surrounding that started as a service. So like, for example, we are in the Gen AI world, so generative AI, so we are seeing more and more number of services. So that's where the demand is, more and more services kept on coming in. Then came in the containerization and the Kubernetes era. This changed the whole game and gave rise to CNCF, which became the Cloud Native Computing Foundation. It has like N number of, I don't even know the count, but there is a finite count, but I would say like N number of projects and tools under that particular specific umbrella. So I think with the rise of CNCF, we have seen overall, like I said, philosophy running in cloud and the process changes kind of is the whole cloud native way of doing things. So we say like monolithic to microservices, which to some extent, yes, is true, because there are still monolithics being deployed and being developed. So not everything is microservice. And we went from servers to VMs to container, but we still are using servers. We still are using VMs. We still are using VMs on Kubernetes, and definitely we are using containers, and we are moving one layer down, which is WebAssembly. So we are seeing a lot of changes happening in this. We are seeing DevOps, then, evolution of that, or addition to that GitOps, and then evolution of that platform engineering to have your own internal developer platforms. your own hardware to cloud. We have seen that particular change, but still, but you can also see people coming back from cloud to their own hardware. So that doesn't mean they are not cloud native. So in the end, cloud native is building a application which is agnostic of the platform, that it can run on any cloud, it can run on your data center, it can run on any of the API based hardware which is out there. Um, so that, I would say, that is, the cloud native way of doing things, and using the modern cloud native tools, which kind of falls in the CNCF landscape. Yes, there are some tools which are not yet part of CNCF, which also do a lot of eases out a lot of process and works for you. But overall, this is what is cloud native. So I wanted to set the context first before we move to the main thing of state of cloud native in 2024. So in this particular video, I'll be explaining 4 key areas where I think 2024 will see a lot of movement. One is sustainability, one is WebAssembly, one is AI, and one is platform engineering. There are other areas where we'll see the continuous growth, but these areas might see some very big disruptions, or very big new innovations and new production use cases, or massive adaptability and things like that. So sustainability, it has become very important to become, or to just be aware of the carbon emissions for your cloud native applications. It has become very, obvious to think about the carbon emissions of your data centers, of your applications, what you are running, how you are running, what is the carbon emission of that from the software perspective. In the end, we need kind of 3 things. One is the measurements, and that can be done on the basis of some tooling to measure the energy for the solutions that we develop and deploy. Second is reduce the code that generate the heavy CPU cycles and memory allocation. Why I say the heavy CPU cycles and memory allocation? Because those actually are the frequency and capacitance that gets mapped when we calculate the sustainability carbon emissions. Identifying the working hours of the environment and turning off during the night hours. So some of the very common things that everybody can kind of think, analyze, do. So with that, we have a CNCF Technical Advisory Group for Environment Sustainability, which is tag ENV sustainability.cncf.io. Tag ENV supports the CNCF community and its open source projects to become more sustainable. So that there is a new tag in sustainability in CNCF for sustainability, which is a very big thing. So CNCF, you can see CNCF itself is pushing sustainability of not only the cloud native projects, but also helping in the evolution of the tools, making an umbrella for the open source projects like it always does, so that people can contribute, create, and innovate on top of that. So we have now a sustainable cloud computing landscape. You can see it is divided right now into 4 areas, which is infrastructure tooling, observability tooling, data centers, and methodologies. And for example, let's take the observability. So you have the G profiler, you have Kepler, Kubernetes based efficient power level exporter, you have green metrics tool, you have cloud footprint, cloud carbon footprint, you have influx data telegraph collectors that can actually collect those metrics that can tell you the carbon emissions for a particular application. Then you have your infrastructure layer. So you have your scheduling, platform aware scheduling, carbon aware scheduling, and then basically you can have some of the nodes in the low carbon footprint data centers, and you can have your workloads deployed over there, things like that. But then the intelligent auto scaling also coming into there. Then you have predictable vertical pod auto scaler. You have KEDA that can help with Kubernetes event driven auto scaling for carbon neutral stuff. And then you have resource tuning that can be done with Kubernetes Power Manager, Extensible Power Manager. So one such tool is like Kepler, which is a CNCF project, falls under sustainable computing. Kepler is the K8s based efficient power exporter, and it uses eBPF under the hood to capture all the metrics and then passes that metrics to machine learning models that then analyzes that data, enriches that data, and again exports as the Prometheus metrics that gives you the exact carbon emissions for your specific applications deployed on the Kubernetes clusters. So you can see there is a node. Every node has some containers running on them, every pod running on them, and every pod is having some containers running on them. And containers are nothing but just a Linux process, which are just a Linux namespace isolations and stuff like that. And everything that is running as a process contributes to the energy consumption, because that is CPU, GPU, RAM, power, everything is contributing over there. How are we measuring? So this is what I was telling when we were first discussing this, like the reducing the number of heavy CPU cycles. So usually it is measured by the capacitance and frequency. But we cannot measure it directly. So for workaround, what we do is capacitance, meaning the number of circuit running, and we make it like we count the number of CPU cycles when we are talking about the softwares running on the hardwares. And when we talk about the frequency, it is the every circuit frequency, and how we calculate that is we read from the CPU counters like the APERF counter and things. This is how the dashboard of Kepler looks like. So you can see you have power consumption in all namespaces. You can see the total power consumption in all namespaces, and this is kilowatt hour per hour all namespaces. And you can filter by namespaces, you can filter by workloads, you can sort it. So different stuff you can do, and this gives you overview of what your power consumption carbon emission is for your application in which particular namespace. You can also filter by namespace and see which namespace is contributing more towards the carbon emission in the workloads that you have deployed. So Kepler, in short, is energy consumption by the pod. Metrics captured using eBPF sent to ML models that can be online and offline. I have a full deep dive video on Kepler with the demo on Cube Simplify. You can check that out. Then generating meaningful data, because that after it goes to ML model and it then enriches the data, so you get the meaningful data, and then you can use those Prometheus metrics to create fancy dashboards using Grafana and stuff. So now let's try to understand another CNCF project, which is Cube Green, which is an operator to reduce the CO2 footprint of the clusters. Interestingly, we all have multiple clusters. Like we love having multiple clusters because we have dev, stage, prod, and even test at times, and there can be multiple environments. Not all the times all the clusters needs to be running. So there are like thousands of pods running 24/7, contributing to the CO2 emissions from multiple clusters that you do not need at times. So I think that is the time where you can make your pods in specific environments go to sleep. So Cube Green is an operator that is installed on Kubernetes. You can, or an admin can, create a custom resource sleep info, and it can, like for in this particular example, you have a sleep info kind, and on weekdays, so it means that shut this particular workload down on weekdays, sleeping at night 8 p.m. to 8 a.m. in the morning with respect to European time zone, and suspend cron job as true, exclude the deployment API gateway. So you can exclude different specific deployments from that you do not want to sleep, basically, which are critical for some pieces of your applications to still functioning if somebody is testing or doing something. So why I told this? Because we will see more and more tools coming in conjunction. So what you can do is you can get the metrics from the Kepler, and then you can take action and reduce that to reduce the impact by scaling that to 0. So in 2024, we'll see more adoption of such tools. We'll see CNCF projects measuring their carbon footprint. This is actually a part in the working group itself that is working towards measuring the carbon footprint of CNCF projects. We'll see more green data centers. So CIVO partnered with Deep Green, and that is like carbon neutral data centers, because they reuse the data center heat to power or to heat up the swimming pool. I think which is dope, and we are already using it. And I think we'll see more innovation and more innovative solutions like this. Also innovation with new projects in this space. We'll see that. More and more education on how to go beyond politics. This is very important, because whenever we talk about sustainability, we always think from a perspective of, political leaders and stuff like that. But as devs, as software engineers, as working in the software industry, IT industry, I think it's very important that we focus on that area first where we can take, use, and create an impact from our side. And then, yes, the community is growing bigger and bigger, and you can be part of it. So make sure to join the tag, be in the meetings. I think it is the right time to get involved in a very bright tag, which will going to shine in 2024. Next one is WebAssembly, my favorite, and creating some content around WebAssembly specifically as well. So just to set, again, I'm setting the context and then going through the 2024, what the state in 2024. So WebAssembly defines a portable size and load time efficient format and execution model specifically designed to serve as a compilation target for the web. So this statement is taken by one of the quotes from Luke Wagner. I think that perfectly summarizes what WebAssembly is, because it is actually the compilation target. So this is the concept, like a user writes the code in Rust. You use the same tooling. So the tooling was not matured before, but it is very much mature now. So you do use the same tooling cargo build, just put the target as wasm32 wazi. You get a .wasm file that can run on any architecture. This was the timeline, so it's not a very new concept. We have been seeing the attempts made for running something apart from JavaScript inside the browser from ASM.js time onwards. So WebAssembly was initially announced in 2015, and we saw more and more progress of WebAssembly on browser in 2017. First public working draft with thread support got in 2018, and 2019 was the year where we got massive attraction from the cloud native side of things and the server side of things because of Wazi, that lets you run WebAssembly on the server side using WebAssembly system interface. Then the expansion of Wasm ecosystem with more tools and languages and frameworks in 2020. 2021 was about first draft component model, and 2022 Wazi specification 2, core specification 2. 2023 mainly around polishing those component model, polishing the WebAssembly preview 2, and WebAssembly machine learning inferencing, a lot of AI inferencing use case. So 2024 WebAssembly goes mainstream with superpowers. AI inferencing on WebAssembly, we'll see more and more. Wazi reaching to 1.0. Hopefully by end year, we'll see Wazi 1.0. I think preview 2 with networking support will be out in very early 2024. Component models, specification to be finalized. This is what people are very excited about. What it means in a nutshell is, let's say you have developed a particular piece of library that is very powerful, and that is written in Python, and I am writing a Rust code, and I can use your library because I also need that functionality, and I don't have to rewrite it. With component model, I should be able to reuse what you have written. So it's similar to, importing whatever you love in whichever language that is solving a specific problem that you also need to solve in your code. True polyglot kind of applications that you will be able to build with component model. More adoption based on innovations like more adoption-based innovation. So we have seen, companies like Wasmer, Wasm Edge, Second State, they are also building not only with respect to specifications, but also apart from it where the user demands are there. Like, WaziX, which is Wazi on steroids, like it has many features. Onyx, a new programming language powered by WebAssembly. So we are seeing new and new stuff that is in demand, which might or might not be 100% with respect to the specification, but it serves the purpose. So we'll see more innovation in that area as well. Wasm and Kubernetes, very interesting space, going to, boom in 2024 for sure, because with the rise in and the maturity in the Run Wazi project, Run Wazi Shims, that lets you run WebAssembly workloads on your existing clusters. And we'll see more and more cloud providers natively providing that option, where you can create a new node and make it WebAssembly compatible by default and run your WebAssembly workloads on your existing Kubernetes clusters or new Kubernetes clusters. AKS is already doing that, and we'll see more and more cloud providers joining this and providing this feature. And we'll see also more and more WebAssembly in production use cases. Next up is platform engineering. Very interesting topic, very hot topic of 2023. I think it will be even more interesting in 2024. So very very short, like obviously we are not going into the very details and the specifics for each of the sections that I'm discussing over here, because I just want to cover the state of cloud native in 2024. But I do have content on Cube Simplify covering most of the stuff in detail. WebAssembly one very soon is coming, but platform engineering, I already have a video. But in a nutshell, in my opinion, it's the next iteration of DevOps. And you can, I mean, to some extent, you can say that, internal developer platforms are something that is built as part of platform engineering, which is the next iteration. What that means and why do we need it? So let's try to understand that. So let's say there is a team A. Now team A is having a server, GitHub, where they push the code, and Docker, where they build the app. But for their infrastructure, they use Terraform, and for their CI/CD, they use Jenkins and Argo CD. On the other hand, there is team B in the same organization that uses a server, GitHub, Docker, but they use Pulumi for their infrastructure, GitHub Actions, and Flux for their CI/CD. Now you can see, right? There is something off over here. Nothing off with the tools. The tools are awesome. Jenkins is cool. Argo CD and Flux are dope. Infrastructure tooling as Terraform and Pulumi is great. And GitHub Actions is awesome. Then what is off over there? Like if you try to think for a second, take a moment and think, like, what is off over here? They are in the same organization. And still they are using different tools. Now imagine a scenario where you have 10 different projects, 10 different teams working with infinite number of different combinations of projects. It can lead to a big mess because you need a lot of people to manage that. You need a lot of cost for these tooling. There is no compliance. So there is no, standardization. So with platform engineering, what happens? There is a single platform. So you can see in the image, there is a single platform. A user or a developer just says, I need a Kubernetes cluster. They will have an API or a UI, which they'll request it to, which is actually the platform. And the platform will give a 3-node cluster. That's it. They don't need to specify which cloud. They didn't need to understand about the standardization. They don't need to understand GKE, CVO, or whatever Kubernetes cloud provider they need. They don't need to understand, or they don't need to do POCs on that. So it does standardization of tooling across the organization, because as organization, the platform engineering team will take the decisions based on the security best practices, based on the compliances, based on the tooling maturity, that these are the set of tools for different areas that we'll be using for all of our projects. So it makes standardization of tooling very much possible with platform engineering. Self-serving API-based platform for devs. Dev love APIs and UI. You can give them the APIs and which they can consume without knowing much about, I need Postgres from AWS, I need RDS, I need whatever. So they just say, I need a database with X GB of RAM. That's it. They'll get a database with the credentials. That's pretty much it for the IDP that they'll get. Abstraction of services. They don't need to know what they are getting. They just specify, we need a database, we need a cluster, we need this, we need that. That's it. Less complex. It becomes less duplication because users or teams do not have to duplicate the setups of production-ready setups of different CNCF tooling for each project. You have a production-ready setup, you just keep creating, clones of that. Security and compliance, as I mentioned, it will be there. Cost reduction and FinOps is also a part of platform engineering. So that's what it adds, and that's why it is very important. And in 2024, we'll see more and more projects popping up in this space, more and more projects, open source and not vendor neutral or maybe vendor specific, basically vendors popping up in this space, easing out either creation or adoption of the internal developer platforms. So more startups with opinionated solutions, because it's all about opinionated solutions. What works for one might not work for other. So it all depends on the opinionated solutions. Then more and more adoption within the organization. The CNCF white paper, which is already there, it will get more adopted, read, and more standardized best practices for deploying, creating internal developer platforms. So 2024 is a very big year for platform engineering as well. The last one that I want to talk about is cloud native and AI. So everyone knows generative AI got mainstream in 2023. We saw at KubeCon, Priyanka had, big things to talk about AI, OpenAI, and Kubernetes. How OpenAI gave their keynote a long time back at KubeCon, stating how OpenAI is being powered by Kubernetes. So Kubernetes has become kind of that uh, piece of technology where everything is powered, like it is powering every piece. And with growing, we can see the growing CNCF AI tooling. We can see more and more number of projects coming into this space. Like for example, Kate's GPT just got accepted to CNCF sandbox. It is getting massive adoption. So we are not only seeing the enhancements within Kubernetes to cater the machine learning workloads, we are also seeing enhancements in or the new innovation in this space where new and new projects are coming in for solving different challenges using the generative AI, which got mainstream in 2023. So 2024 brings more innovations, more adoption, ease of deployment, also opinionated platforms for machine learning. So we'll be having an end-to-end platform where from the developing, training and deploying and whatsoever is there involved in the pipeline for the end result, we'll have the opinionated platform for this. We'll also see GPU sharing, how GPU sharing works, more and more slicing of it, more availability with smaller providers, more interesting services from smaller provider in the machine learning AI space. We'll also see eBPF and AI, some stuff going around in this. We also see more and more observability startups, including AI to auto detect and auto fix some of the fixes with respect to Kubernetes when it comes to Kubernetes, because cloud native is what we are talking about today. So I think that's pretty much it from the 4 areas that I wanted to cover, which is the sustainability. We're definitely bound to grow. WebAssembly, yes, it in Kubernetes ecosystem as well. We'll see, WebAssembly as an extended scheduler for WebAssembly. There's works going around over there, and it's definitely going mainstream for the server-side WebAssembly and cloud-native WebAssembly with respect to Kubernetes, Runwazi, Shim. Platform engineering going mainstream in 2024 with more adoption, more innovation, more opinionated platform. Generative AI and AI ecosystem is also one of the hot topics that will continue to thrive in 2024. So that's pretty much it, what I had to share for the state of cloud native in 2024. I hope you enjoyed the video. Do share your views on what you think will be the state of cloud native in 2024 and which areas you will see more adoption or innovation or production use cases in 2024. But in my opinion, these are the 4 key areas to look for and get involved in 2024. Thank you so much for watching this video.